So for problem F4-14, we'll be determining the magnitude of the moment of the force F is equal to 300I minus 200J plus 150K newtons about the x-axis. Now I'm going to show two different ways that you could possibly solve this problem. The first one would be using the cross product, where the moment about the x-axis is equal to ROA cross F. And I've already solved for the position vector, so let's just go ahead and put this down as ijk 0.3, 0.4, and negative 0.2, and our force is 300 minus 200 plus 150. And since we're just solving for the moment about the x-axis, we are going to again use the cross product, where we have 0.4 times 150 minus 0.2, negative 0.2 times negative 200. So writing that down, we're going to have 0.4 times 150 minus the negative 0.2 times negative 200, and this is I hat, which comes out to be 20I Newton meters. Since we're just doing it about the x-axis, that would be our moment about the x-axis. The other way we could look at this is, so I'm just going to go ahead and erase this force here, and then I'm going to put the forces in their direction, where this is x, which is 300 newtons, we have z, which is a positive 150 newtons, and we have y, which is going negatively. That's what I'm showing with the arrow, drawing it negatively, so that's going to be 200 newtons. Now, since I'm summing it about the x-axis, I'm going to draw a line through there. I can visually see that this 300 Newton force is parallel to the x-axis, so it cannot cause a moment about that axis. But this 200 Newton force, if we pull on this pipe system along the y-axis, along the j direction here, it will cause a moment about that axis. Same as if I push up on this 150 newtons, it will also cause a rotation about this x-axis. So the moment about the x-axis then is equal to, if we're looking at this 200 Newton force, 200 newtons, its distance is going to be this 0.2, because we got to get up to that 0.2 meters, and it is going to be causing a rotation that is clockwise, which is going to be a negative 200 newtons times 0.2 meters. And then this 150 Newton force is going to be causing this rotation, which is a positive rotation, so plus 150 newtons, times, now this distance, if you can see, I'll draw a line of action through that point. You can see that this 0.4 meters is going to be our perpendicular distance. So this 150 newtons times 0.4 meters, this is all in the x direction, which is going to land us with a 20I Newton meters. So either way you want to do it, you can use the cross product, or you can use scalar issue, where you're just doing a force times a distance. Or again, you can use the vector or the dot product vector analysis as the moment is equal to R cross F. All right, thanks for listening.